Hello friends, welcome all of you. Today I am going to discuss with you one of the most important terms used in the spectroscopy. Out of which the first is a wavelength. Okay, it is the distance between the two identical points on successive crest or the cleft of wave is called as a wavelength. It is the distance between two identical points on successive crest or cleft of wave is called as a wavelength. Okay, it is denoted by letter lambda. Okay, it has different units depending upon the nature of electromagnetic radiation. Okay, in UV visible spectroscopy, it has unit Angstrom or nanometer, where the 1 angstrom is nothing but the 10 raised to minus 8 centimeter, or the 1 nanometer is nothing but the 10 raised to minus 9 meter. In IR spectroscopy, the wavelength having unit or wavelength is measured in units of the micrometer, where the 1 micrometer is equal to 10 raised to minus 6 meter. This is all about the wavelength. Next important term used in spectroscopy is the frequency. Okay, it is the number of complete cycles. It is the number of complete cycles or wavelength passing through a point per second is called as a frequency. Okay, its unit is cycles per second, in short form CPS. It is also denoted or called as hertz, HJ. Okay, suppose this is a complete cycle. When it is completed in a specific time, then it is referred as 1 cycle per second. It is called as a 1 hertz. When it is past the specific distance, then 1 cycle per centimeter is called as a 1 per centimeter. Suppose 10 raised to 6 cycle per second is equal to 10 raised to 6 hertz, then 10 raised to 6 hertz is also referred or called as 1 megahertz. That means the frequency has made it to its hertz or megahertz. This frequency is interrelated to the velocity of light and wavelength of radiation. Mathematically, it can be expressed nu is equal to c upon lambda. Okay, frequency is expressed or denoted by letter nu. Nu is equal to c upon lambda, where the c is a constant velocity of light, 3 into 10 raised to 8 meter per second. It is constant. That's why nu is equal to constant upon lambda. Okay, so this nu is inversely proportional to the lambda. That is, frequency is inversely proportional to the wavelength. That means the shorter the wavelength, more the frequency, or the larger the frequency, or larger the frequency, shorter the wavelength, vice versa. This is all about the wavelength and the frequency. Next term, wave number. It is denoted by letter nu bar. It is the cycles or wavelengths per centimeter distance is called as a wave number. The number of cycles or wavelength per centimeter distance is called as a wave number. It has unit per centimeter or the quasars, where the 1 quasar is equal to 1 per centimeter. Mathematically, wave number is expressed nu bar is equal to 1 upon lambda. That is, wave number is inversely proportional to the wavelength of radiation. Okay, next term, amplitude. it is denoted by letter A. The maximum displacement of wave from x-axis is called as a amplitude of radiation. Okay, the maximum displacement of wave from x-axis is called as a amplitude of radiation. Next term, velocity, it is denoted by letter C. It is the distance traveled by a wave in unit time. It is the distance traveled by a wave in unit time is called as a velocity. It can be expressed in centimeter per second or the meter per second. In vacuum, velocity of radiation is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. That is, it depends on the medium through which it travels. Okay, mathematically velocity of light is expressed c is equal to nu into lambda. C is equal to nu lambda.